I'm going to go through the three problems on homework 12. The first question says that you want to estimate the mean age of the Bay Area population. You don't know the shape of the population, but you do know that the standard deviation of the population is 15.7 years. You randomly select 40 people from the population, and you record their ages. This question is asking you to pretend that you're doing a survey in which you're recording the ages of a random sample of 40 people. You just need to make up your own 40 ages, like I did here. You can make up any 40 ages that you want as long as they're all whole numbers. I made up my own 40 ages just so I could take you through the steps of the problem. The first part says to calculate the mean age of the sample. To get the mean age of the sample, you just add the 40 ages and divide the total by 40 and write the answer. The next part says calculate the standard error. When you're calculating the mean of a sample, the standard error is the population standard deviation divided by the square root of the sample size. The question says that the population standard deviation is 15.7, so I plugged in 15.7 right here. The sample size is 40 because I have 40 people, so I plugged in 40 right here. 15.7 divided by the square root of 40 is 2.48. That's the standard error. The next part says, can a margin of error be calculated? When you're calculating the mean of a sample, like we are here, you have to use this rule to decide if the margin of error can be calculated. The margin of error can be calculated if either the population is normal or the sample size is at least 30. The question says that you don't know the shape of the population. You don't know if it's normal or skewed. So this first part doesn't check off. But our sample size is 30 or larger. We have a sample size of 40. So this checks off, and the answer is yes. The next part says calculate the 95% margin of error. The first step is to go to the z coefficient table and look up the confidence coefficient that goes along with 95%. The z coefficient that goes with 95% is 1.96. So we plug in 1.96, which comes from the table, and then we multiply that by the standard error, which we found in part C. And when we multiply, we get our answer. The 95% margin of error is 4.86. So the 95% margin of error is just the z coefficient from the table for 95% times the standard error. The next part says to create a 95% confidence interval. When you create a confidence interval, you take the sample statistic and you add and subtract the margin of error. So in our situation, we're going to take the sample mean, which came out to 34.78, and add and subtract the 95% margin of error, which came out to 4.86. And we're going to get two answers by adding and subtracting. And the confidence interval is just the interval between the two answers. So since my two answers were 29.92 and 39.64, my confidence interval is 29.92 to 39.64. I just took these two numbers and plugged them in right here. So what I did in part F is I took the sample mean, which I found in part B, and I added and subtracted the 95% margin of error, which I found in part E. And when I added and subtracted, I got two answers, and those two answers are the endpoints of my 95% confidence interval. When you take a sample mean and you add and subtract the 95% margin of error, you get a 95% confidence interval. Part G says, what is your conclusion? When you create a 95% confidence interval, you're 95% confident that the population parameter or statistic that you're estimating is somewhere inside of the confidence interval. So I'm 95% confident the mean age of the Bay Area is somewhere between 29.92 and 39.64. In other words, I'm 95% confident that the population mean that I'm estimating is somewhere inside of my confidence interval. That finishes first question. The second question is similar, but it's a little bit different. The second question says, you want to estimate the mean age of the Bay Area population. You don't know the shape of the population, and you also don't know the standard deviation of the population. The population standard deviation is unknown. You randomly select 30 people from the population, and you record their ages. This question is also asking you to pretend like you're doing a survey. You need to make up the 30 ages in your sample and fill them in. Just fill in some made-up ages. I filled in my own ages just to take you through the problem. The first part says, calculate the mean age of the sample. To get the mean age of the sample, you just add the 30 ages and divide the total by 30. When I did that, I got 33.7 as my sample mean. The next part says, calculate the standard error. We're going to have to calculate the standard error differently because the population standard deviation isn't known. When the population standard deviation isn't known, you can't calculate the actual standard error, but you can calculate an estimated standard error. To get an estimated standard error, you divide the standard deviation of your sample by the square root of the sample size. You just substitute the population standard deviation for the standard deviation of your own sample. So the first step is going to be to find the sample standard deviation. To do that, to find it, you have to take the 30 data values, subtract each one by the mean to get deviations, square each of the deviations, and then add the squared deviations to get a total, divide the total by n minus 1, or 1 less than the sample size, and then take the square root of the answer, and that gives you the sample standard deviation. This is just the same formula that we used earlier in the class to find the sample standard deviation. The symbol for sample standard deviation is S, so my S came out to 11.68. When you find the sample standard deviation, you can just round off your sample mean to a whole number, so you don't have to deal with squared deviations. For example, I took my sample mean of 33.7 and rounded it to 34, and just plugged in 34 right here, and I subtracted every number by 34 to get my deviations. Now that we have the sample standard deviation, or S, we're one step closer to finding our standard error. What we have to do next is we have to divide the sample standard deviation by the square root of our sample size, and that'll give us the standard error. So I took my sample standard deviation, 11.68, and divided it by the square root of my sample size, which was 30, and that gives me my standard error, which is 2.13. So 2.13 is the answer, and it's actually an estimated standard error because we plugged in the sample standard deviation instead of the population standard deviation. Now we'll move on to part D. Part D says, can a margin of error be calculated? We're calculating the mean of a sample in this question, so we're going to follow the same rule. Either the population has to be normal, or the sample size has to be 30 or larger. Once again, we don't know the shape of the population, so this doesn't check off, but the sample size is 30 or larger, because it's 30, so this checks off, and the answer is yes. The next part says to calculate the 95% margin of error. Since we calculated an estimated standard error instead of the actual standard error, we're going to have to calculate the margin of error a little bit differently. Instead of plugging in a z-score, we're going to be plugging in a different value called a t-score, which is basically an adjusted z-score, or a corrected z-score. To get the t-score, you have to go to a different table that I'll show you. You don't go to the same table for z-scores. So you go to a table called a t-table, and you look up the t-score, and then you plug that in right here. When I went to the table, it told me that the t-score was 2.045, so I plugged that in. And now I'm going to multiply that by the standard error, which I found in part C. Remember, it came out to 2.13. After we went through all of those steps, we got to 2.13. And then when we multiply, we get 4.36 as the answer. So when we multiply the t-score by the estimated standard error from part C, we get our 95% margin of error. The next part says to create a 95% confidence interval. To do this, you do the same steps we did in the first problem. You take the sample mean, which we found at the beginning of the problem, and you add and subtract the 95% margin of error. In part G, the 95% margin of error was 4.36. So we're going to take the sample mean and add and subtract 4.36. These are the two answers. So our confidence interval goes from this number to this number. And our conclusion is, once again, I'm 95% confident that the mean age of the varia is between the two endpoints of the confidence interval. That finishes this question. So this question was similar to the first one. The only differences were we had to calculate an estimated standard error using the sample standard deviation, and we plugged in a t-score instead of a z-score. The third problem is also asking you to pretend like you're doing a survey. It says that you want to estimate the proportion of San Jose State students who live with their parents. You're estimating a population proportion. You randomly select 40 people from the population, and you ask each person if he or she lives with his or her parents. In this question, you need to make up a data set like you did in the other problems. Each person's answer will just be a yes or a no, so just make up yeses and nos, like I did here. To calculate the proportion of the sample that lives with their parents, you need to find the number of people who said yes. You need to count the number of people who said yes, and then divide that by the sample size. I have 28 yeses, so I divided 28 by my sample size of 40, and I got my sample proportion of 0.70. So 70% of my sample says that they live with their parents. The next part says to calculate the standard error. In the formula that we used before to calculate the standard error of a proportion, we had the letter P, which was population proportion. But in this problem, we actually don't know what the population proportion equals because we're estimating the population proportion. It's unknown. So since the population proportion isn't known, we just replace it with what we do know. We replace it with the proportion of our sample, p hat. P hat is sample proportion. So what I'm going to do is plug in my sample proportion of 0.70 as this number right here. So it's going to be 0.70 times 1 minus 0.70 divided by our sample size of 40. You just multiply the two numbers on the top. You get this answer, and you divide by 40, and you take the square root, and then that's the standard error. So this is actually an estimated standard error because we substituted the population proportion with the proportion of our sample. The next part says, can a margin of error be calculated? We need to follow, when we're calculating a sample proportion, we have to follow this rule to decide if the margin of error can be calculated. This is the same rule that you've seen before in proportion problems. Usually we do n minus p, and n times 1 minus p, and p is population proportion. But if the population proportion isn't known, like how it isn't known here, you just replace it with p hat, sample proportion, as a substitute, and you just multiply. You multiply n times the sample proportion, p hat, and you multiply n times 1 minus the sample proportion, p hat, and you look to see if they come out to 10 or larger. They both came out to 10 or higher, so since they both checked off, the answer is yes. We can calculate the margin of error. This says to calculate the 95% margin of error. when you're calculating a margin of error for a proportion, it's always z. It's never t. So we just have to go to the table and look up the z-score for 95%, and it's 1.96. We multiply that by our standard error, which came out to 0.07. That's what this came out to in part C. It was 0.07. And then we get 0.14. So once again, the margin of error is just the confidence coefficient times standard error. Now that we have our 95% margin of error, we can create our confidence interval. To get our 95% confidence interval, we just have to take our sample statistic and add and subtract our 95% margin of error. In this problem, our sample statistic is p hat, which is the sample proportion, the proportion of people who live with their parents in our sample. P hat came out to 0.70, so we have to do p hat 0.70 plus or minus the margin of error of 0.14. The two answers are 0.56 and 0.84. So the confidence interval goes from this number to this number. What I did here is I just took the sample proportion, p hat, 0.70, and I added and subtracted the margin of error, which I found in part G. It was 0.14. And I got two answers, and those two answers are the endpoints of the confidence interval. And just like in all confidence interval problems, or just like in all problems, when you calculate a 95% confidence interval, the conclusion is that you're 95% confident that the population parameter that you're estimating is inside of the confidence interval. In this case, I'm 95% confident that the proportion of San Jose State students who live with their parents is between these two numbers. And that's the end.